Uh, I don't know if do we have to practice clearing the calculators? Can I trust you to do that a week from today? Right at this time next week, you'll be taking that Regents. So, all right. Everyone all right clearing their calculators? We're all right? Second plus 7, go over to all memory, reset. We're good? Please, please don't stop me. All right, when I'm flying up and down the rows, I got 80 kids in there. I got to figure out their calculators. Everyone's all right? Supplies, we're all good? Seat numbers, we're all good. Okay. I'll open it up to you guys. Anything in the August 2017 Regents, all right? This is where we're going to start today. Anything, and I know which one's going to get asked, and it's going to take a while. Kate? 13? No, that wasn't the one, but I'll, of course, do it for you. 13, yeah, a little tough one. Everyone take a look at 13. Again, we're on August 2017. All right, here's the deal here. I am going to rotate this rectangle around a straight line. It might be the long side, it may be the short side, it may be the vertical line of symmetry, or it may be the horizontal line of symmetry. I rotate this around. Regardless of where I rotate it around, what type of figure am I going to get? What solid am I going to get when I rotate it around any of those 4 lines? It's going to be a cylinder. All right, that was the first thing here because they don't come out and say it's going to be a cylinder. A cylinder with a volume of 150 pi. So what I needed to do first was go to my reference sheet, which is going to be provided to you, and find the volume of a cylinder, which is pi r squared times the height. And now I'm going to go through each choice right now and plug in the corresponding radius and height and see which one's going to give me 150 pi. So let's do this first one, the long side, which is the 10 side. Rotate it around the 10, rotate it around the 10. What's that 10 going to actually be for me in the formula? That's going to be my height. All right, and now think about it. Rotating around the 10, rotating around the 10. What's the 6 going to act as? That's the radius, because there's going to be 6 here and another 6 on the other side for a full 12 for a diameter. So I'm just going to leave 6 squared here. And if you do that, I believe that's 360 pi. My math's correct. So it's not going to be the long side. I do it for the short side now. Now how do my numbers change? What's the 6 going to be? Height. And now what's my radius? 10 squared. Okay. Now I have no idea what that ended up being, but now let's go to the vertical line of symmetry. Now you're going to rotate it around this line. Oh, there you go. Okay, now we're going to rotate it around this line right here. What's your height now? 6, but now be careful. Because what's your radius now? 5, okay? And then the same would be true if I did the horizontal line. Height would be 10, radius would be 3. So I test all those values out, see which one gives me 150 pi. Good question. We good there, Kate? Yeah. Meg, you had a question. Yes. 17. Everyone 17, please. Okay, partition. Okay, what was the issue? All right, let me ask you then what you did to find the x value. Which was what? -8 and... Okay, so you went from -8 to 16. That should have been a distance of 24, right? Yeah. All right, then you divided the 24 by 8. Perfect. And got 3. But you're just not going 3 units. What's the first number in that ratio? So it's 3 times 3. You're going to go 9 units from -8. All right, that's your starting point. So you got to go -8 plus 9. That'll give me the 1 there. Okay. Let's keep going. August 2000, Jasmine. 23, everyone. Oh, good. This is one I was going to go over eventually here today before we close this exam out. All right, everyone may want to focus in on this one because it's got a little something something at the end we haven't gone over in ages. Area of a sector. We're going to know the formula in a week or not. Area equals measure over 360 times pi r squared. Congratulations, Colin. Okay. Congratulations, Colin, advancing to the finals. Business. We're on this area of a sector problem. Jasmine, this was your question, correct? Okay. All right, so there's my area formula. Anybody? There it is. All right, so we're looking for the area. I have the area of the sector. That's 512 pi over 3. We are looking for the measure of the angle, so I'm going to solve for m. This isn't anything new to us until the end. Times pi, what's my radius? Should be half of 32, 16 squared. We've talked before, what do they both have on both sides that are eventually going to cancel out? The pi's are gone, so I'm going to take 512 over 3 equal to m over 360 times 256, I believe. All right, how are you going to get m by itself now? How can I get, there's really two ways I could go algebraically here. I can multiply both sides by 360, or I can multiply or divide both sides by 256. Your call. What do we want to do here? Multiply both sides by 360. You got it. So on this side, I'm going to end up having 256 m equal to, I know it's a huge number, but times 360. I have 61,440. Go ahead, everyone. Divide by 256. M is equal to 240. All right, let's talk now, because here's where the change comes in. That's 240 degrees using that formula. Go back, reread the problem. What do I need to leave it in? Okay, now we got to review how to convert. You don't need to remember the conversion because it's on your formula sheet. So everyone's got a formula sheet on the back of this Regents. Please go there now. You will see on the formula sheet, 1 degree is equal to how many radians? Pi over 180. So if you want, you can make a proportion out of this. 1 degree equals pi over 180. How many degrees do I have? 240. And I want to know how many radians that is. Everyone take a look at what we've just created up here. There's the conversion off the formula sheet. Degrees stay with degrees. Radians stay with radians. Everyone all right? So I end up with here, x equals, what are the two things you got to multiply? $240 times pi over 180. Now, everybody stop before we start hitting buttons on the calculator. Look at all your multiple choices. What are they all in terms of? Pi. They all have pi in them. So you probably don't want to hit your pi button right now on your calculator. All you want to do, probably by the looks of the multiple choice answers, are reduce 240 over 180 on your calculator. Get it back into a fraction. Because they're all pi's in the answer anyway, so I shouldn't just leave pi. I should just leave pi where it is. And it ends up being 4 pi over 3. Jasmine, how are we doing there? Okay. Everyone all right on this one? I had a lot. You had to know the darn sector formula. You needed to know how to solve for the measure, and then you're not even done yet. You had to put it into radians. Oh, good. That's for arc length. That's for arc length and radians, not for sector. Now, look, there is a sector formula for radians. It's in the packet. I never went over it during the year, Katie. So if you want to remember that one too, that's on you. But I never went over. This is the only formula I gave you guys for sector. But there is one for radians that's in there. But SOAR, you're thinking S equals theta R. That's to find the arc measure in radians. Yep. Okay. Colin? Oh, you have another question. Anybody else on this one? We all good? Okay. How do you feel about yourself? Big winner? I have so many questions after the vote. I don't want to ask right now because it could influence people's, but I have a lot of questions for you guys at the end once the votes are in. All right. 18, Colin? Yeah. Good. It's a good question you asked. I'm not a big fan of it because I don't like testing hills and SAS this way, but this is the way they did it. And I didn't. We've discussed this. I didn't even look at the problem. I know it's a hill SAS just by the diagram. I could see right triangle altitude in there. Boom, it got to be a hill SAS problem. And here's what it's asking. Which one of these, with the 16 on KM and these multiple choice values, which ones fit into hills or SAS perfectly? So that's what we have to test, each one individually. So everyone look at choice one. I got LM is 13, KN is 6. I got to see if that fits in the hills SAS correctly. So I got to first figure out which one to plug it into. Is altitude involved? Altitude involved here. Did I label the altitude at all? No. So I'm going to see if it works in the hills. H in the hills, hypotenuse. What is it? So here's what I'm asking with choice number one. I am asking, is 16 over, what's the L, the leg in this case? Leg, 13. Does 16 over 13 equal 13 over, what's the segment I want to use because it's not 6? 10, the one next to the 13. Is that true? That's what you need to figure out. 13 times 13, I believe, is 169. 16 times 10 is 160. That doesn't work. So it's not 1. It's got to fit in and equal each other on both sides. So now I go to number 2 now. And I say, all right, LM now is 12, NM is 9. Still going to use hills because the altitude's not involved. So 16, what's my new leg? 12. Is that equal to 12? What's the new segment? 9 or 7 here? 9. 1 next to 12. And if you cross multiply there, I believe you get a $1.44 equals a $1.44. So that's the one I want to use. That fits into hills and SAS correctly. Not the way I would like to test it. I like it when it's you get to pick which one, plug it in, and solve for X, but it's the way it was on this one. Colin, you good? Okay. Everyone else see how that's done here? Good questions here, guys. Any others here we want to go over? Because I'm not done with this exam. There's multiple choices I wanted to go over yesterday that we didn't get to. Nothing else on this exam before I pick a couple. Okay. I just got to find them. We went over 4, correct? We actually did do that one, right? Did we get to 7? And then the chaos started. 12 then. Let's go to, I don't know if I did 12 or not. I don't think we got to 12. Maybe you did on your own because you've been following along, but I don't think we went over it as a class. Just one more circle thing I want to go over. I feel pretty comfortable in the circle review we've been doing. PB is 3. BC 15. Find PA. you're not too sure what's about to happen, look on your cold hard fact sheet. All the circle stuff is already there. I have a secant and I have a tangent. I don't care about the angle here. I'm looking for the lengths. I'm looking for the lengths. So here we go. Let's start this off right with number 26. What can I set up here? There you go. Whole times external equals whole times external. Anytime I involve secants and tangents. All right, moving on. 16. Give me the whole secant length. Do I have a 16 in the house? Hi, Emma. Whole secant length? 18. How about its external length? 3. 22. How about that tangent length? How about the external part? Also x. Also always the same for tangent. So we have 54 equals x squared. Take the square root. Looks like we'll have to break it down. Anybody? Biggest perfect square that goes into 52? 9 times 6. So it ends up being 3 radical 6. And I know we've talked about this. You do not have to have the ability to break it down in this case, because you could just check the square root of 54, find which decimal matches. Comments, concerns here? Yeah, you're hungry for another one. 22. Regular decagon. Let's stop there. Decagon? 10, yeah. I wasn't a big fan of this question just because of that, because you have to know it's 10 sides. That's something. That's on you. I don't know. We've taught it. We've gone up to 12, I believe. So. All right. 11. I don't think you need to know that. I think it's an unagon. Unagon. All right, moving on. And then here comes this term we've seen a few times already. Carry it onto itself. Meaning same exact size, same exact place. I don't move location. All right. I turn it all the way around. How many degrees did I go? 360. That's never going to be a choice. I could get that same decagon back if I did it 360, but it's never going to be a choice. But on my way to 360, how many times could I see that exact decagon back in that location? 10 times. Matches the number of sides. So minimum number of degrees I could rotate and get that decagon to carry it onto itself is 36. Not going to be an answer, probably. That's the minimum number of degrees, 36. Probably not going to be an answer. All right, next, I could go another 36 and get 72. Not a choice. You got to figure out, keep going 36 degrees till I see one of these choices up here. That's what it comes down to for this problem. And it ends up being 252 degrees to get it to carry it onto itself because it's divisible by 36. Everyone all right? They seem to have one of those on every year. What's going to carry it onto itself? Anything else? All right, Jasmine already asked the next one I was going to have, which was 23, so we're good with that. And then I think we're good with the exam. We are. Okay, so I'm done with that one. Unless you're coming in to review and want to ask me questions, I'm moving on to June 2017. You got as you walked in, and we're going to 32. Go ahead, 32. You have two triangles you can graph. What do you need, Liz? Get your act together. You got a Regents in a week. 85 or above. Got it? By the way, 7th period, confident as ever. Confident as ever that they're going to beat you. I had no comment. And then I think they start smarting up and they're like, well, maybe if we eliminate your average and your average, maybe we could do it. All right. First part. Can we now reading clutch here? Determine and state the single. I don't want two here. One and only one that will get ABC onto DEF. Think about it, because I don't want to give this one away because it's not that bad. All right, so don't tell me rotate, slide. All right, I need one and only one right here, guys. It doesn't say describe a sequence, only one, a single transformation that'll move that bad boy over. You don't have to do it now. Oh, or you can, sure, Alan, go ahead and. Vincent, think you got it. There it goes, right there, right here. Everyone take a look at this line Vincent is talking about, this vertical line right here. It's got a lot of arrows, looks pretty classy. Now, you can write what he said in words, or you can do it in symbols. Let's talk symbols. What is the symbol for reflection? Lowercase r, little r, lil r. Yep. X equals is always a vertical line. Y equals is a horizontal line. Or again, if you're unsure, just write it out in words. We'll take it. Here's why I wanted to do this problem. The exact wording we're going to have to write down to prove that triangle ABC is congruent to DEF. Well, what did you just do? What did Vincent tell us to do? A reflection. So a reflection is a rigid motion. Tell me a little something. Which? What about rigid motions? Conserves, preserves. Preserves what? Angle measure. And distance. You can put side length if you're feeling that crazy. Angle measure and distance. Now, speaking of crazy, whatever you'd like. Triangle ABC congruent to DEF. All good. I just want to make sure we went over the wording. Hungry for another, of course. All right, I don't have the time. If you have a compass on you, go ahead, you can try it, get it out and use it. I don't have time to go back there and just bombard the filing cabinet, so you can just pay attention and watch. This is a rare moment where I go over construction, considering there's 80 videos up on YouTube about how to do every one we've done this year. And I'll tell you why, as we're doing it, why I picked this one to do specifically. It's nothing crazy. It's asking us to draw an altitude from J down to ML. Refresh. What's an altitude do? Oh, perpendicular to the side we're drawing it from. So I need a perpendicular line starting from J down to ML. And here's the reason I'm doing it. The answer to this question is not, let's do the fish like it usually is. This isn't a fish construction. That's why I picked it. All right. How do I end up with a perpendicular line coming from a point? First, where should I be putting my compass point? Anybody want to help? On J, the vertex that it's coming from. I have a feeling this is going to be a disaster with this. Okay, next goal, make an arc. Intersects ML twice. That's not going to happen until I extend ML out. Yeah, that's not going to work today. And then from there, now you go to each endpoint, and you can do these next two arcs below or above. It doesn't matter, as long as they intersect each other. So there's one arc. Go to the other point of intersection with the same opening on your compass. Make those two intersect. Come on. Any day. There we go. And then line it up your straight edge with point J and that point of intersection, and we should be good to go. And I've been saying this since I showed you your first construction way back in September, October. Leave all the markings on your diagram. Do not erase anything. That's how it is corrected. Any issues there? Just wanted to show you it's not always a fish. Construction. What time? Oh, we got plenty of time. 8. Another circle. I think we've covered our bases with circle questions. All right, a lot going on here. BC is 12, and what also is happening to BC? It's getting bisected by DF, so anybody want to throw anything on C or CE or EB as numbers go? 6s. That 12's getting bisected, so 6 and 6. And then what do you guys, FE is 5 more than DE. What are we throwing on DE? X, all right. We're going to throw X plus 5 or 5X on EF. Yeah, we're better than that. Don't be an embarrassment next week. Don't embarrass me. Don't embarrass me. I don't know. What do I do with these now? This is not a whole in external because there is no external. What's it say on the sheet if I need it? Need to reference it here. 2 chords intersect. What should I be writing for an equation to solve here? Oh boy. Oh, big number here. Let's open it up. 16 Yep, this is a part times part. Give me a part and a part of the same chord, Emma. Go. 6 times 6 equal to, oh boy, 30. Oh, here we go. Thank you. Maybe you do belong with all of us, Paige. Okay. $36 equals x squared plus 5x. Oh, yep.
Oh, yeah.
What's going to happen here? Got a little factoring going on. Move the 36 over. So we are not, can we all be in agreement right now? We're not going to be surprised if we need to factor next week. Quadratic formula will be on your reference sheet if it's needed. Anybody got those two numbers that multiply to 36 but are 5 apart? 9 and 4. What about the signage here? -4 plus 9. So you get two values out for x. You get x equals -9 and x equals +4. Anybody want to discuss anything? Reject which one? -9. Not because it's negative, though. Why am I rejecting it? It gives us a negative segment length, which is a no-go. So I get x equal 4, and everyone's like, whoop, whoop, choice 4, choice 4. But I didn't read the problem. There goes your 100 to a 98. Congratulations. Did not read the problem. One job, finding FE. So what am I looking at? 9, yep. All right, this next one, I want you to work up to the bell on your own. If you finish, let me know. I'll check your answer real quick. All right, this is going to be a little tougher one, so if you want to work with people around you, that's fine. There's nothing there. There's nothing there. There's nothing there anymore. There's nothing there. What do you want here? I just want to put the pen down and just say, work on the darn tank. There's nothing on the line. I went through all that yesterday.
Monday is a lot going on. Shut up! You have to make a TikTok with me.
No.
No. You have to make a TikTok with Al.
No. No. I think I've given up enough. What's it going to be then?
Curtains. Clock.
Curtains again. Clock. Clock. Genie. Here you go. I don't even know why I'm putting myself in this position. Probably because I like you. I will. If you guess the next one, Promethean Man, or you get to guess it here in the next 3 minutes, I will teach Monday's class in Emma's life vest. All right. So here we go. If this comes up again, I'm just going to regret this. Anything else you want me to add here? Stars. Curtains. Genie. So we're going Star and Promethean Man for the vest. Star or Promethean Man?